Good morning, participants. Hope I am audible. Please write on the chat box. I am clear and loud. Thank you. 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 Thanks. So, behalf of the IIITNR Raipur, behalf of the all the coordinator of this FDP, I, Dr. Vivek Tiwari, faculty in Department of Computer Science and Engineering at this institute, welcome you all the participants in this 1 week long FDP, which is supported by ATAL AICT scheme. And I would like to convey my thanks to all the participants, researchers, faculty members, students who have shown their interest in this week-long FDP. So since in last 2 years, AICTE already inaugurate the couple of FDP that are going to be conducted in the next 1 month. So we are not going to conduct a dedicated formal inaugural session. So this is the first session. As already mentioned in the schedule, we are going to start our talks. So I would like to convey one small information about this FDP, like in the PPT it is already mentioned, or in the schedule you might have observed that it is a part 2. So who are already attended this FDP in the part 2 that was conducted in October 1st to 5th October in the last year 2021, that no. But when I see the registrations list and I found there are more participants in this part 2 FDP than the earlier participants. So there is a mixing audience are there. So it's my responsibility to make it clear. The first part of the FDP is already over in the last year. This is the second part of the same FDP. Who are new, don't worry about that. Who are continue that FDP in the as a part 2, don't worry about that. The FDP schedule content, the experts are invited in a such a way that who are attending this FDP as a part 2 already attended will feel the fresh content. The content will not be going to be repeated, and you will find the new learning. It's my sincerity. Moreover, on the other hand, who are first time attending this FDP, so don't fear that something you have missed, something that you need to be covered in the part 1, and so that you are going to face some difficulty in the part 2 because you have missed the part 1. So don't worry about that. Since I have seen the many large number of participants are fresh in the part 2 FDP, so you will not get any kind of difficulty. You will not face anything that is in the term of prerequisites. Something happened already in part 2 and we missed it. That's why I'm not going to understand the advanced topic of the FDP that are going to be delivered. It is not going to be happen whether you are present in the part 1 or not. The FDP syllabus content experts are called in a such a way you will feel and you will enjoy the FDP, you will learn a lot, and that 5 days going to be a learning environment for all of us. So that was the small uh, update about the FDP. As intentionally I have taken the first session since I have seen the many of the students are or faculty members are belongs to the different departments, and they might possibility to don't have basic understanding in the new area if they are going to switch their expertise and research in the new area that is called machine learning, data science, that area, deep learning. So they may be new. So in the first lecture is totally dedicated to introduce the basic modeling. What is a modeling? Various terminologies like training, testing, categorical variable, nominal variables, and and various tools that I'm going to use throughout the FDP tools, techniques that is going to be covered in the session 1 today. So that in the coming session, when expert come, other faculty member comes, they will assume that the participant have this much of basic understanding. They will use those terminologies, those understanding as assumptions. So the first lecture is totally going to be about developing the basic understanding of the machine learning, data science, or other terminologies that are essential to understand. So that's why the title of the first lecture is giving that modeling terminologies and tools. Before starting the session, typically content that I have decided, let me discuss about the small guidelines that you need to understand. It make your journey very much happy. Like attendance, like it is not my rule, it is a AICTE guideline. 80% attendance is required. The question may be with you how the attendance is going to be conducted, how I'm going to quantify, going to measure the attendance. The attendance link I have every day randomly. Please try to understand randomly. Maybe in during the session 1, session 2, or session 3, maybe any session, or maybe multiple sessions. I will forward the link for the attendance, and you have to give your attendance throughout the Google form. That is actually Google form. It may be conducted once in a day, anytime, twice in a day, or thrice in a day. So it's up to randomness kind of things. So you have to give your attendance, and at the last of the day, I will going to calculate the attendance. If it is 80%, it's okay. If less than 80%, you will not be allowed to get the certificate. It's the AICTE rule, and I will be little bit strict on the attendance. So please be attentive. Attendance link may be shared anytime during the day, and you have to give the attendance. It may be single time, it may be multiple time. So any of the questions regarding the attendance, you can ask uh, after the session in the WhatsApp discussion. We will make it. So here only about the attendance. Similarly, based on the contents being covered during the 5 days, at the last, a small quiz of the MCQ based quiz will be there. 60% marks required. So quiz will not be a big task. All the things are covering under the FDP. The small questions will be there. Certificate will not be issued by either me or either through my institute. Once you fill the two criteria, the three criteria, your attendance should be 80%. I need to fill your attendance in the AICT portal. I need to fill your quiz marks in the AICT portal. Third, you have to give your feedback. So through the AICT portal, after the 5th day, the link will automatically will open, and you have to give your feedbacks. So from your side, three formalities are there. First, attendance, quiz, and feedback. The three things are over. Within a 24 hour, the AICT will release the your certificates, and it will be available in your AICT account, or they may be shared with your email ID, whatever you have given. Okay, I have created the first WhatsApp group, and who have not joined till date, please join, and all the discussion we will make over there. During the session, such kind of discussions are not important. So whatever the query and anything you want to make the clarification, you may write on the WhatsApp group. Whenever I have time, I try to reply it. So these are small guidelines, you can say, or instructions that you need to follow throughout the FDP. Thank you. So at the first lecture is very important, and the content that I have planned to cover during the first session was I will touch upon the model development life cycle, because in machine learning, AI, data science, we talk a lot about the model. I want to develop the model, model X, model Y, model Z. What is the model, modeling like that? I will try to cover it. Since FDP is not only covering the theoretical parts, throughout the FDP, will try to conduct many hands-on sessions, especially all my sessions will be hands-on. I will try to it. So whatever the basic understanding you require to particular language, so there are other experts are there, they may use the Python, some expert will use the MATLAB, I will use the R. So at our level, if you don't have exposure of any of the language that experts are using, maybe R, Python, MATLAB, don't worry about that. It is a matter of syntax only. So it will be very easy because the experts and who are the resource person, I have requested to explain each and every part of the function, library, code you are using during the lecture, you try to explain. So whether you have not expertise on the particular platform and tool, don't worry about that. It will be easy for you. Since I'm going to use the R, so I will cover in the R installations, how to import the data into the R, how to display the data, how to check the data types and variables. I will cover today. And also will try to demonstrate how to split the data, how to divide the data into the training set and test set, like that. Rescaling about the data I will also cover. And all those things are going to be hands-on. So that was the point of discussions I have planned for the today's session. Going ahead, starting with the word algorithm and the model. If you ask yourself in what is the difference between algorithm and model? So the person are new in the field of machine learning, especially in the graduates, undergraduate students, they get confused. What is the algorithm and the model? So well, I will start from here. 1 minute, let me open the file. I hope this file is enough clear to you and visible. Please write on the chat box. This new file just I have opened. I want to just confirmation the file is this doc file is visible to you all. Model development life cycle. I am
Yes,
just.
visible.
Oh, thank you, thank you, thank you. So like we have seen, if you are a student from, you are the student from the computer science, we have taken the subject software engineering. There were a subject where we talk about how to develop the software model, and software development life cycle was the full chapter in that book. Similarly, model is also kind of product. Like a software is a product, model is also product. So you want to have a product with you, you need to follow some phases. You need to go phases one by one. All the phase that you need to carry to get the ultimate model, that process is called the model development life cycle. So basic fundamental steps I have written over there. In machine learning, problem is given to you. I assume that whatever the problem is given to you, to solve that problem, there are many algorithms out there, many solutions out there. There is no only single solution. So you have to select the particular algorithm that you are going to use to solve that problem. That is called algorithm selection. So a lot of domain expertise you require. What kind of problem is given to you? It is supervised, unsupervised, like that. And all those algorithms are capable to handle those kind of data or not. There is a text data, image data, or time series data, sequential data, or unstructured data, whatever the data is with you in the given problem you have given. So based on that, you have to select the algorithm. So the first step is that algorithm selection. And once the algorithm is with you, you have to go for the training phase. Training phase means learning phase. You have to feed your data set to the algorithm. The algorithm learn from the data. I will discuss in detail what is the meaning of learning. So algorithm learn from the data. So once the algorithm is learned from the data, it become a model. So the difference between algorithm is model is that algorithm is simple, the steps that you need to follow, or in the simple word is the mathematical equation that do nothing, that don't have any capability to take the decisions. Algorithm don't have capability to make some action. But when algorithm learns something from the data after the training, it become model. So model is something that you can say it is a more intelligible form of algorithm. It can take the decision. it can act something based on the input you have given. But whatever the model you have, it is not so simple to say about that you have training process is over, your model is ready. No, you have to check your model. What was the expectations were there in the given problem, whether your model is fulfilling that expectation or not. That process is called model validation or model evaluation, where we evaluate the model. Like after the course, we evaluate the students. We need to evaluate the model. Once it is all things are acceptable, then the sky is open. A lot of optimizations technique you can apply to improve the performance of your model, maybe in term of accuracy, maybe in term of speed, maybe in term of underlying memory it is required. Okay, so model optimization means any of the dimensions you have taken, maybe memory, maybe speed, maybe something, and you want to improve it. So this is the whole life cycle is the we need to follow, called the model development life cycle. So model and algorithm is, I hope it is clear to everybody. I will take 2-3 minutes more to discuss about the algorithms and the model. You see in the between, it is the algorithms, only the mathematical equations you can consider that. You feed the data. Once you feed the data, algorithm become the model. So if you try to ask, sir, without training, without the data, algorithm cannot be model, more or less it is correct. You need to go for the training. You need to feed the data to the algorithms, then it become only model. So model is something that take the decisions. I found that is very interesting discussion with the newcomers. What exactly happened in the training? What magic happened over there? How is something algorithm that are not able to do anything? So what happens? Something it become a model, start predicting something, and how the magic comes from? What exactly technically, if you try to understand mathematically, if I say conceptually, we know learning training, what mathematically it happen inside the algorithm, so the algorithm become the model. I will take 2-3 more minutes to discuss about that part. You see, first diagram, then I will explain the second diagram. In the training, suppose I will cover what is supervised learning, unsupervised learning. The diagram is for the supervised learning. The data is given to you, and the training labels. Training label means correct answer. Whatever the data set you have designed, you need to be given. In the whole data set, there will be some input variable. And if you feed the input variable to the data, what should be the output variable? So that is called true value. So real output variable always be given in the data set, so that during the training, when algorithm learn from the data, algorithm start predicting something. So whatever the algorithm is predicting, whether it is meeting or matching with the true value or not. So that is called training labels, means true value is given to you, that is called target value. So once algorithm is predicting during the training, how close it is to the real or target value, that we need to match during the training. We will try to increase the matching of predicted value and the real value. That is the objective of the training. So once it is over, and when the training is mature, we say that this training is over, I can't learn much more from the data. So it becomes the model, and then you can use for our purpose. So what happened actually? Suppose this diagram is given to you, that is typical linear regression algorithms I'm talking about in the machine learning. So if the people know about the linear regression is the fundamental most studied algorithms comes under the machine learning as statistical data analysis. So linear regression is nothing but a simply equation of the line. So I have written y is equal to mx plus c, it is written. So here c means b0 plus b1 x1. So it is mx plus c, it is written. So that is a linear regression. So you need to feed the data to this equation, mathematical equation. So you might have observed here b0, b1 are the coefficients that we need to estimate during the training. So the objective of explaining this diagram is that so that I can make clear what happened in the training. What happened in the training? Whatever the coefficients are there in the algorithms, whatever the deep learning you are using, millions of coefficients are there. Whether you are using decision tree, whether you are using Nebase, KNN, whatever the algorithms you have, logistic regression, SVM, there are coefficients. So like B0, B1 are the parameters, and sometimes some books mention over there. These are the parameter you need to estimate it during the training. Sometimes we call the coefficient. So in the algorithms that are symbol, they don't carry any value, any number. But after the training process, what happened? This equation may be like that: y is equal to 5 plus 6x1. So how does come from 5 and 6? It comes to the training. These values, the algorithm learns 5, 6, 7, 8, 9, 10 with the different values, against which set of values of all the participants my predicted value is matching with the target value. So that settings come in a such a way that matching should be more perfect, more accurate. So with that way, there are many training algorithms are defined inside that help us to estimate the value of parameter and coefficients. So that happen actually in the training. Your algorithm become a model in such a way that I have explained. Okay, so I hope it is clear. Uh, Going ahead, modeling. So modeling is a word. So it contains two things. Modeling contains training and testing, both the things. So what is the training? What is the testing? So who might have many of the participants have understood training is something where the algorithm is given to you, the data set is given to you, correct answer is given to you, and it is a iterative process where the training data contain the correct answer, and the correct answer known as the target attribute or output attribute. It is supervised learning. So during the training, what happened here? We find the patterns, we find the relationship. Those relationships help us for the predicting or for the mapping the input and to the output. So let me take the example, then it will be very good. Yeah. For example, the student data is given to you. Most of the you are the trainer and teacher researchers, so they are familiar with the example. Suppose student data is given to you. Okay, data is like that: student name, okay, 10th, 12th, CGPA. I'm here writing the CGPA. What a CGPA or percentage, whatever you want, CGPA percent. First semester to, suppose student from the BTech, 8th semester, CGPA. It's a communication skill, if you can write it, technical skill, like that. For here you have a data, previous data, yes or no. Means in campus drive, placement drive was happen, placement drive. Okay, so that was selected in the last during when he was a student, was selected in the campus drive or not. A data set you have, many students are there, many students are there, thousands of 10,000 students are there. So here I want to develop a model, means whatever the problem is given to you, that problem is given to that a model I want a model such that I will feed I will feed this much of information in the future. Means I will feed the 10th, 12th CGPA, semester CGPA, communication skills good, web bad, excellent, like that, technical skills like that I will feed, and I want to see my model is predicting what in the next year the placement drive the particular student is going to success, yes or not. I want to have a such kind of model, so that in future if the students for those my model predict no, I have a enough time, 1 years to improve their skill. So what happening over here? This is the target variable, because in the application I want in the future what my model is going to predict, that will be target variable, that will be output variable, normally we call, or sometimes we call it class level. So target variable, the words try to understand, we call it the target variable, we called it the output variable, we called it the class level, like that. Okay, many terminologies are there in the different resources, maybe books, and the authors have used the different terminologies. So what I was discussing about the mapping, what happened in the during training. So these are the data set that going to help us to take my prediction. These are called features. These are called features or input variables. Okay, so the more better, accurate, more descriptive input variable you will have, your prediction will be more accurate. So total accuracy of your model will be depend on the type of features, the quality of features you have. So ultimate what model is going to do, it is going to establish the relationship. Establish a relationship between input variable and output variable. Input variable may be many, output variable is single, okay, at a time. So that relationship, sometimes it is called mapping, that I want to find during the training. So that happen. So that's why sometimes we call it, we try to learn the mapping between input variable and the output variable. If you have learned the mapping more effectively, your output will be more accurate accordingly. Okay, so that's the sentence was written over there. The training, the learning algorithm finds pattern in the training data that maps the input data attributes to the target data. Okay, so this happened in the training. The training data you need to give, and your model will learn something. Once training is over, we have to test it. We have to evaluate it. So what happened in the training? How the testing is different from the training? Uh, Let me explain. So we have seen in the training, we need to feed the target data and the input data both. But in the training, testing, we don't provide the target or true output variables. So meaning of that, in the training, what happened? Any kind of training, what happened? We give the input variable plus output variable both, so that we can learn how to map the input variable to the output variable. In the testing, we provide only the input variables. Input variables. We have output variable in other file. Okay, so that is called target variable, or sometime called true value. Sometimes it is called true value. We don't feed the true value or target variable during the testing. We allow your model to predict something. So model will predict something over here. So that is called predicted value. Predicted value. So we have the true value already in another file. What my model is predicting uh, during the testing, we try to match it. We try to match it. How close it is. How close, how accurate it is. So that's we perform in the testing. So if it is not satisfactory, it is not as per your expectation, you need to change the model. You need to change the algorithm, training process, features, many things you have to do. So that is the whole process of training and testing. That is demonstrated through the example. You see the input data, your model will predict, your model already there, your model will predict, and the results is there, you have to analyze it. You have to analyze it. whether it is working or not, how close it is, how accurate your model is. That is the process of training and testing uh, that you need to understand because it is a fundamental backbone of the machine learning algorithms, how to use it, how to develop it. Okay, going ahead, like a features, because sometimes people are using word feature, sometimes they use the variable, input variable, and different terminologies are there. So features are only those things against which we try to define your objects and any concept if you have. Like a student's capability being going to be success in the placement drive is not I'm going to define in the term of 10 CGPA, 12 CGPA, how good he is in communication, how good technical skill he has acquired. So these are the features. Feature is going to define something. It may be an object, it may be an entity, it may be a concept, it may be an idea. So features are the property, characteristics that help us to understand the object. Like a car, a lot of engine capacity, gears, automatic car, yes, no, like that. Uh, 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 Many features are there. So features are very important because if you have a good quality features, your model is going to make you happy. Otherwise, 100% your model is going to fail in the real environment. So the feature understood. That's why feature is very important. Feature engineering is important. Sometimes features are not important. Sometimes features are important. How could you know it? Like for a simple example I have taken here, I'm going to ask a simple question. Name of the student is also a feature, also a variable. So do you understand really? Do you believe really whether the student is going to success in the placement drive or not? It anyhow depend on the name of the student. You may write your answer on the chat box. Placement probability of a student depends on his her name. No, and no, not at all. You are able to answer it. Why? Because you have a domain knowledge. Okay, suppose I have encoded the features. Okay, you are not allowed to see the this is x1, this is x2, this is x3, this is x4. Like that I have encoded the features and will give the same data to you. Then you will not able to answer whether x1 or x5 is not important. So the meaning is that if you have a domain knowledge, you easily identify the feature I am not going to use for the training purpose. So really in the real life, we don't include the name during the training. We remove it from the data set. We delete it. The remaining things are important. Okay. Yes, not depend on the feature. Similarly, student have many others property like the hostel the student have allotted, the room number. Okay. Or you can say PAN number, Aadhaar number. They are not at all important. They are important, but they are not important to decide whether the student is going to success in the placement drive or not. Same PAN number is become important when you're going to decide the student is going to repay the loan or not. A PAN number is better to say their civil score, because suppose assume that PAN number is related to the civil score. So features sometimes become important or not important is directly related to the problem you are going to handle, the applications you are going to conduct, like that. So the features sometimes it become easy if you have a domain knowledge. If you don't have the domain knowledge, like in the biological field, in the medicals, thousands of features are there, and we are going to discuss about the impact of the feature on the particular disease. We can't say this feature is important or not, this value is important or not. So there is a full chapter in the data science and machine learning, the feature engineering. Full course is there. Okay, the 5 credit course may be their full course of feature engineering, where we study about how to handle the features, how to find the features is working or not, feature is important or not, like that, like that, like that. Many of your students when
काइंड ऑफ या ये करके लूँ बट प्रोजेक्ट
I
में लेके
request all the
हम क्या
participants
प्रोजेक्ट
please
आई वाज
mute
प्लानिंग
yourself.
कि आई हैव अ प्रोजेक्ट ऑन द बिग डेटा एनालिसिस
Chandrasekhar,
बट चीज
Chandrasekhar
ये है
Kumar,
कि तुम लोगों का जावा कितना क्लियर है फिर हडूप के ऊपर हम इक्लिप्स के साथ बिग डेटा के साथ कैसे काम कर सकते हैं और अगर जावा में करना चाहते हैं तो इट इज क्वाइट डिफिकल्ट फॉर अस टू इम्प्लीमेंट एन मशीन लर्निंग एल्गोरिदम यस इट इज एब्सोल्युटली लिटिल बिट
let me see.
बट अगर ऐसा सिनेरियो नहीं है और तुम लोगों को आर और पाइथन का थोड़ा बहुत नॉलेज है तो वी विल प्रोसीड विद
Yeah, I have expelled him. Sorry. It is the normal problems with the online classes. No issue. So what happened? Oh, I was discussing about the feature engineering. So I have demonstrated the how important the features are, how to find the features, how to check their importance or not. That you need to understand. I am not going to cover throughout the lecture how to uh, uh, measure the discriminative power of the features. It is not a scope of the lecture, but it should be the scope of your learning. After the FDP, is supposed to learn all those things. Going ahead, class labels means target variable. It is supervised learning if it is there. You need to give the true value, correct value. If you don't provide the correct value to the algorithms, how algorithm can measure and take the appropriate step for the better learning, because the algorithm cannot check whatever it is learning, it is correct or not. So class labels, target variable, output variable are those feature. It is one of the feature. Try to understand. Class label or target variable, output variable is not it is not something new. It is a part of one feature. It should be a feature. Okay. So that feature going to be used to during the training whether my algorithm is learning in the correct direction or not. If it is not going into the correct direction, we can check it, we can take the corrective measures, and we change the learning directions and try to find the optimal model. So these are the class labels. When something and during the next 5 days people talk about the class label, you need to understand what the meaning of the person is intended when they use the word class label etc. Like this. Purposefully, I have pasted that figure because people think about the target variable is always be categorical. It will be categorical, but sometimes it represent in the form of in the form of numbers. Like it is a medical data is given to you that whether the person is going to be all in the history suffered from the heart stroke or not. So the data have a features like age is a feature, gender is a feature, chest pain were there. What was the scale? One, two, three, four. Blood pressure, what was there? Cholesterol, many ECG, many things are given. And also given the class zero means is never suffered from the heart stroke, and one means yes, he or she have suffered from the heart stroke. Zero one means it may be represent in the form of yes or no. So sometimes it's very much common to represent your class label. If that is a categorical class label, yes or no, we may represent in the form of number 0 1. 0 means no, yes means yes, 1 means yes. So here 0 1 is not a mathematical number. So if you're going to apply the mathematical operations like what is the average, what is the standard deviation, it will give you a number, one value, but it will not be interpretable. You can't uh, uh, um, go on any decision. So don't worry about in future if you find anything as the output variable, class label or categorical variables are representing in the form of numbers. It is very common. Like here also you see the gender. 11100. What is the meaning of that? 1 maybe means male, 0 means maybe female, or vice versa. Okay, so these are not a typical number. They don't have mathematical meaning. They have logical meaning. Similarly, this chest pain, it is also a category 1, 2, 3, 4. Low, medium, moderate, high. If you're going to apply the mathematical operations on this data type or this feature, you will get nothing. Okay. Similarly, blood pressure and cholesterol, these are the real number. They have meaning in the numbers. They are not category. Okay. So here, in that way, you need to improve your understanding with respect to the data set, what the data set is given to you, how to understand the features, how to go for the interpretation of those features. Moving ahead, there is a three type of data analytics. So when we talk about the data science or machine learning, AI, yeah, you might have listened the word predictive data analytics, descriptive data analytics, prescriptive data analytics. So many of the books and the blogs and the video lectures, they are going to use such kind of word when they explain some concepts, some algorithms. They talk about this is the algorithms are kind of predictive data analytics. They will talk about, suppose the linear regression is a predictive data analytics, and K means clustering of or principal component analysis is the descriptive data analytics. So many times you may feel in the coming 5 days, many different experts are going to explain the category or type of the algorithms they are using, what type of algorithm that it is. So you need to understand what is descriptive data analytics, predictive and prescriptive data analytics. Mukti Pathak ji,
Sorry, sir.
Mukti Pathak ji still
Yes, sir. Actually, I am having some problem in my mobile, sir.
uh,
Right now,
uh,
please, sir.
you
One
mute
minute, sir.
yourself only.
Yes, sir. Yes, sir. Yes, sir. I am doing so, sir.
Okay, thank you. So we were discussing about the type of data analytics, so you need to understand it. So basically there are three kind of data analytics, and going to explain in next 5 minutes, how do you decide whatever the algorithm you are understanding or learning comes under which category. There is some basic properties and characteristics if those algorithms follow or comes under that property. Based on those property, you can define or you can understand that whether it is descriptive or predictive or prescriptive. Okay, one by one I will take only 5 to 10 minutes, 5 minutes only, not 10 minutes. 1 minute, let me arrange it. Yes, so starting with the descriptive data analytics, we talk about what is happening in my business or what the things have happened. So suppose you are running some business and company, and suddenly you are feeling some hike or profit, or either maybe the loss you are observing. You need to understand why it is happening. So when you want to analyze something happened, what was the reason, why it has happened. So that comes under the descriptive data analytics, because you are looking to describe your data. You are looking to see the patterns inside the happening. You are going to see the artifacts and the patterns that are in the data set. So like pie chart. Many of the learners don't understand the pie chart, bar chart, or any way when you are going to represent your data into the visual format. It is a descriptive data analytics because you are going to describe the patterns, characteristics, your data in the form of pie chart, bar chart, or line chart like that. So whenever in any mode, your objective is to describing your data, it is a descriptive data analytics. Okay. So in the descriptive data analytics, you are not able to predict something. So in terms of the concept we have seen in the last 1 hours, in the yes, it is better to understand. So what happened? What about the concept we have seen in the previous discussion? Like we have the input variable, we have the output variable that is called target variable or class level. You need to learn how to map the input variable to the output variable. It is called predictive data analytics. It is called predictive data analytics because your objective is going to predict in the future, like we have seen in the example, the student is going to be success in the coming placement drive, yes or no, whether the person having a chance to in coming days to heart stroke or not. Those all those things where the output variables are there, where target variables are there, and your objective is to predict in the future based on the data set what is going to be happen. Those comes in the predictive data analytics. In the descriptive data analytics, we don't have the output variable. You don't have the output variables. There will not be true answer will be given to you. You will have only data set. So all those kind of applications where your objective is to see the pattern inside the data, to describe the inside the data, what is hidden inside the data comes under the descriptive data analytics. In the descriptive data analytics, there is no kind of such mapping between input variable to the output variable because there is no true value, there is no output variable. So it is called unsupervised learning. Unsupervised learning, if you have listened that word. So descriptive data analytics is a kind of unsupervised learning. And what are those algorithms and comes under the descriptive data analytics or unsupervised learning? Why it is called unsupervised? Now you can understand. Because there is a no target variable. There is no true value that help algorithms or that helps to check the algorithms. Algorithm is going in the correct direction, yes or no. So there is no supervisor. There is no supervisor. What is the meaning of supervisor during the PhD or MTech? Whenever the student and new PhD scholar start research working, it is the responsibility of the supervisor to keep him or her in the right direction. So that is called supervisor. There is no supervisor. Nobody is going to give you idea whatever you are doing is correct or not. So here there is no target variable. Who is the supervisor here in term of data set? Your target variable, your output feature is the supervisor. So in descriptive data analytics, there is no supervisor. That's why it is called unsupervised learning. So that is the understanding of the terminology that were evolved. Algorithms talk about unsupervised learning, clustering, all the clustering algorithms. Whatever the clustering algorithm you have, you like the k-means clustering algorithm, hierarchical clustering, DB scan, if you know all those words. PCA, principal component analysis, a priori algorithms, association rule mining, association uh, 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 rule mining, a priori algorithms, a priori, all are the unsupervised learning. Going ahead, the predictive data analytics, like we have seen, there is a supervisor. So all the predictive data analytics like that linear regression or decision tree having both kind of capability, SVM, logistic regression, like that. All are the supervised learning, because you are going to use those algorithms for do some prediction. Prescriptive data analytics is something that is a mixture of descriptive and predictive data analytics. Here it is need to say about uh, more. It is a kind of system. It is not an algorithm, I must say. It is a kind of system. So what happened in the prescriptive data analytics? Prescriptive data analytics, it will give you a lot of options. Actually, in the predictive data analytics will give you the answer, only one answer, whether the person is going to success either no or something. If you have multiple classes, only one prediction it will make. Only one prediction it will make. It will not give you the choice. But in the prescriptive data analytics, what models does, it gives a lot of choice. And also it gives what happen if you choose this option, then what may happen. If you choose option B, then what may happen? If you option C, what may happen? So that's why it is written. We talk about what do I need to do? What should what action should I take? So it is more helping way to take the decisions, because it talk about a lot of choice, and each and every choice how it is strong and weak. So what kind of applications you can think about that, like a chess game or any kind of games. Most of the AI game or any kind of games you used to play, they are the prescriptive data analytics. Because in the chess game, what happened at the particular situation, particular move you want to make. So a lot of options you have actually. A lot of pieces are there. Okay, a lot of pieces are there. Any piece you have to select. Particular piece you have a multiple movement. It is very easy. Suppose you have a knight, in many directions it will go. Okay, you have a rook, in many directions it will go. So particular piece you have select for a movement, multiple movements are there. So if you go in that movement, your situation is going to be strong, it's going to be okay, it's going to be make you in poor condition, put you into the poor conditions. It also suggests. So this kind of settlement, when we see in game like situations, ultimate what we are doing prescriptive data analytics. I hope it is clear. Going ahead, so like the category already we have discussed about the unsupervised learning and supervised learning, and under the supervised learning, many algorithms are there, like classification and the regression. One by one I will cover in the future in the coming days of the FDPs, I mean to say. So what is classification, what is the regression, like that. Similarly, unsupervised learning like dimensionality, reduction, clustering, or unsupervised learning. There is a more third category of the learning that is called reinforcement learning. So mostly the prescriptive data analytics kind of applications you may observe under the reinforcement learning. Okay, like robot navigation is given, driverless car, where the agent is given to you and you need to put that agent in totally uncertain and very complex environment. And your agent or software, you need to make some decision, continuous decision he has to take. And there is a policy of reward and the punishment. There's no supervisor, you have to take your decisions. If your decisions are going into the correct directions, anyhow you have to find it out, then that actions will be rewarded. If whatever the decision you have taken, it is not making your condition good, it is making your condition poor, it may be penalized. So the reward penalty is a iterative process. Continuously you have to apply, and anyhow you have to, whatever the goal is given to you, you have to find it out. Suppose goal is to for a robot navigation, goal is given to reach from place A to place B, and in between there are a lot of hurdles are there. There are turns are there. You have to take right turn. Hurdles will be there. How to solve it? The multiple solutions are there of the given problem. Such kind of situations, and whatever the learning and concept you are using comes under the reinforcement learning. that is again the type of all those algorithms I have explained. Okay, here, okay, so suppose data set is given to you. Now you are in the situation, you have understood basic terminologies, and you need to perform the modeling. So you need to split your data set into the two parts, because same data set you are going to use for the training and testing purpose. So you need to keep some portion of the data separate for the training. The remaining portion of the data you need to keep for the testing purpose. You remember the training and testing? In the training, the input and output variable both will be given to the algorithms. In the testing, we keep out the output variable and only feed the input variables. Whatever your model will predict, we need to match with the output variable, and we'll see whether your model is giving the satisfactory performance or not. So the word is here, the machine learning is a subset of computer science. It's give a computer ability to learn without being explicitly programmed. That I will cover in the next lecture. What is the meaning of explicitly programmed or implicitly programmed? So that we have discussed already. Correct answer we need to give like that, like that. So what is normally culture or policies we follow in the machine learning? Around 70% data, whatever the data set is given to you, we keep for the training purpose. It may be 75, it may be 80, so don't worry about that something is hard and fast. It is more or less 70% data we keep for the training purpose. It is written with labels and with the answer. And remaining 30% data without target variable, we keep it. And we test the performance, in the real-time performance, we check it. Okay. So that is called data set split, training and testing. 70% data around for the training purpose, remaining for the testing purpose. Now, type of attributes. There are many other type of attributes. Basically, I have taken three kind of attributes. Attribute means that feature. Attribute means that input variable. Like my name is a attribute, CGPA is an attribute, pen number is an attribute, pass or fail it is an attribute. All those are attributes. So attributes is you can connect yourself with the type of data that feature is going to contain. So it is not the type of data that we have seen in the C or C++, like it is an integer or it is a numerical or it is a character. Like it is not like that. It is more logical understanding of the type of data you are going to feed into the particular attribute. Like three kind of basic fundamental attributes are there. There are many more. I have not included purposefully in this lecture because in one day everything cannot be understood. So first category is the nominal or categorical data. Another is ordinal data. Third is the continuous data, and there are many more. But we are going to understand only three kind of attributes that we may have. One by one I will pick up. So like a categorical data when I talk about, or nominal data when I talk about, means it is a category. And that category don't have any order. Okay, like male and female. Male is a category, female is a category. In the feedback, you are happy or sad, it is a category. You are going to pass and fail, it is a category. Like a hair color. Hair color is a category like a red, brown, light brown. These are the category. You cannot make the order between these categories. So like this is number one category or highest top class category, then the sequence you cannot make it. Okay, so if there is a category, but under the category there is a no ordering, there is no sequence you can, logical sequence you can establish. So such kind of situations is we call the categorical nominal variable. Okay, another is ordinal variable. Ordinal variable means it is a type of categorical variable, but one difference. Whatever the category or subcategories are under there, they have some orders. You can arrange it with the logical meaning. How? like income status of the particular person. Suppose the data set is given to you, the customer data set is given to you, and the one feature is there, uh, economic status, means it is a low, medium, high. It is a poor or middle class person or rich person, like that. So here high is a category, medium is a category, low is a category, but you may have order between them. You may arrange it between them. There is a logical meaning you can come up with that one. So this is called the ordinal variables. Okay. For example, suppose what is your gender? So gender, like male and female, is what? It is a category. It is a nominal variable. Your hair colors are a nominal variables. Where do you live? Like, so I'm South Indian, I'm North Indian. So he lives from belongs to the eastern part. So part of particular place is a category. You cannot make the order. But when he asks about the feedback, how do you feel today? Very happy, very unhappy, happy, very happy. This is also category, but it is a ordinal variable because there is a order between there. How satisfied the feedback when you give satisfactory, non-satisfactory, like that is a category. Where you award the student like a grade A plus A, B plus B. Say. These are the category, but there is an order. That's why they are ordinal variable. They are not categorical variable typical. So that is understanding that you need to understand. And other variables like salary, your age, all are the continuous variable or all the real numbers that we call the continuous variable. So typical number, mathematical number, okay, that have mathematical meaning. So when you are going to represent happy, unhappy with the 1, 2, 3, 4, 5, that is the ordinal variable. That is not a continuous variable. Continuous variable have a real mathematical meaning like my salary, like my age, like that. Okay. So these are the some type of variable we have seen. Now the time to demonstrate the tools that are most of the my class. If the lab will be there, I'm going to use that tool. Even you are from the different department, different expertise, don't worry about that. This is not only machine learning tool. R is not a language for only for machine learning. Almost all kind of people, maybe from science background, maybe for management background, maybe for other background, they use the tools a lot for their data analysis. So I hope with that all the participants have know some couple of tool and language that are high demand in the field of data science and AI, like Python, R, or MATLAB. So like a Python, R is so much powerful, high demand, a lot of job, a lot of career options are there with R. If you don't have any background with the R, don't worry about that. I'm going to cover one by one. So first I will show you how to install the R in your laptop or desktop. So the link is given to you. If link is not given to you, just you type on the Google R Studio. Type on the Google R Studio. Okay. R Studio means like a uh, editor. Like a Python is a language, but you need to download either Anaconda or Spider or something else. Those are the editors that enable the programming. So similarly, there are many studios are there, many editors are there. One of the editor that are so famous and widely used is the R Studio. Okay, so you type in the Google R Studio. Okay, go to the rstudio.com. It is like a Python is a freely available. It is free. R is free available, and based on the operating system you have in your system, like a Windows 10, Mac, Ubuntu, you go and click on download. It is only exe file, and you might have observed that the size is required only 156 MB or around 200 MB. So it is not a platform or tools that require huge computational power, huge GPU or CPU. Even the simple laptop, you can install it and it will work for you. So based on your choice, you can download. It is a exe file. So it's very damn simple to installation. Just click on the exe file. It will keep on installing one by one, one by one, one by one. They don't demand anything like I need to configure something. The server you have to make, multiple clients you have to make. Not at all. Very simple, like a zip file you install, like any kind of software install it. It's required only around 200 MB space that I think everybody having in their system. So that is about the tool. Once it installed in my system already there, I'm going to open it. RStudio, type it, click it. It will appear in the screen within a second. Yeah. So I'm not going to teach much about the tool because our objective is not here to learning the tool, working of the tool. Instead, we will give our focus on the algorithm learning. But for a simplicity, very fundamental things I will talk about. A lot of options are given over there as a menu. Many things you can do with the menu. Here is the part, a white color space is given left hand side is the part or space where you can write your command. Like I have written one command, enter, it will give you the output. So whatever the command is there, you have to write. Just press the enter button, it will execute and the associate results will be visible to you in the next line. If the results are in the graphical form, maybe chart, pie chart, it will appear on the right side over here. That you need to understand only two things. What other options are there? I'm not going to discuss. I want to keep my lecture very simple. This is the area where I'm going to work over. Okay, that thing is over. The two things you need to understand: working directory concept. So there is a two command: get wd, get working directory; set wd, set working directory. Working directory means what? That is, you can say the root directory. So in the machine learning or data science, you need to access your data set multiple times. So when you import your data into the R environment, I'm talking about the importing. What I'm discussing, how to import my data. Because the machine learning data science is about only the data, how to import my data. So data is somewhere in the system. It may be online. It may be somewhere in the your drive, C drive, D drive, F drive. So since multiple data set, multiple times you have to access your data. So sometime, every time you have to import your data into the R environment. So you need to write the complete URL, complete path like C, desktop, like. So I want to avoid that thing. So what happened? Root direct is if something you have saved in the root directory, the benefit of the root directory is that you don't need to write the complete path, complete URL, because whatever you will search, you will type, the system, our system automatically going to find it out into the root directory. So whatever the data set or the data you are working or you need to work, the guideline is that you save your data into the root directory. So that when you need to access your data, you don't need to write the complete path again and again. It makes your programming easy. That's a fundamental concept. But data sets are sometimes very huge. So you can't save your data or move your data here and there, or it is not desirable to GBs of data to store in the one location. Another option is that data, wherever it is in your system, you keep their data. You change the root directory. You make that directory where the data is there that you want to work, make that directory as a root directory. So how to do it? It's I'm going to demonstrate. So getwd is a command that will check what is the current root directory is. Yeah. So getwd, whenever you type it, getwd, just enter it. The current root directory is this. Okay. Suppose for a moment, my path. Okay, suppose I want to import my data, that my data is here. Suppose this insurance or text file I want to import. So I will make that path look as a root directory. So I'm going to copy that path. Yes, the command is given set wd, double quote, copy paste that URL, just make it as a backslash. One changes you have to make carefully so that it won't give any syntactical error. Let me do it. Yeah. So again, get wd. I have reconfirmed. Uh, I have successfully changed the root directory. So what the benefit over there? Whatever the things are there in this root directory, I can access in one go. Okay. So that is, I've talked about the root directory, working directory, and how to change it. Now talk about how to import my data, because I have to work with the data, how to import my data. So R comes with all the capability to work with all kind of possible data sets you can imagine. It may start from the text data, CSV data, Excel data, JSON, image, video, semi-structured data, XML, HTML. What kind of the data is possible? That data into the R environment. So here, the objective is not to learn the R completely. Just since most of the experts and me going to use the CSV file as a data set. So I will demonstrate how to import the CSV file. So there is a two command to import the CSV file, read.table or read.csv. I will not discuss about the read.table because the read.csv is more better function that comes a lot of simple form but powerful to work with the CSV file. So if you have a CSV file as a data set, like let me explain, insurance is a data set, suppose. Let me open that data set first, then I will import that data, I will display to you in the R environment. It's taking a bit time. Yeah. Suppose this is a simple data set, okay, having 1, 2, 3, 4, 5, 6, 7 variables are there, 7 features are there, like age, gender, BMI, children, smoker, region. Some data set is there. Suppose you assume that is a big data set, okay. So the data set is in the CSV file. So how to import my data into the R environment, okay, that I'm going to demonstrate. So here the dedicated function, the read.csv, the function I'm going to use it. The function is very simple. You see, read.csv, you call it. Since insurance.csv file is in the root directory or working directory, you can write directly name. It will import my data. I'm going to save into the some variable. So the variable name, whatever you want, you can give. It is like integer A, B, C, D, whatever the variable name you prefer, you can give it. Okay. Just copy that command. Okay. I'm going to paste it. Use this command, I'm going to paste it. Okay. Here you can use the equal to also. Don't worry about that. This equal to operator you can apply. Is more simple. Enter it. Within a second, the whole data set is successfully, because there is no error it has shown. So successfully uh, uploaded into the R environment. Now use that variable, whatever the variable name is here. Yes. Some questions I have seen. How do Roshni Dubey ji has written a question. How do I will get the data that you have? Have you created any created? Okay, I will share. Okay, don't worry. The data set I will share. I will make a repository and will share the link. Then all you may download that data. Okay, or the data is already publicly available, like insurance.csv. The question was about the data set. Okay, so don't worry about that. The data set, you do one thing. All the publicly available data I have used. So let me explain. Yeah. So the insurance.csv, you type it, you will find, look, in Kaggle it is there. So I'm not going to use any of the data that is not available publicly. So just you type it, it will be there. Okay, thank you. So the data set will be there, and we have seen the data is successfully uploaded into the R environment. Yeah, the whole the data set is there. You see, whole data set is there. Okay, now I can work with the this variable because this variable contains the complete data. Okay, and other file like data set is in the online. The read.csv file or function is so powerful. You may feed the link or the URL that is available, the data set from there. It can directly import it. Next question, how validation is done after training if you don't keep the data for validation purpose explicitly? If you don't have data, you can't go for the validation. So the validation you require. Without the data set, the validation process cannot be over. Yes, you can provide the link. Aditi ji, you can provide the link. So in the Kaggle, if it is publicly available, means if there is not required username password, it is publicly available. The link you can directly give. If that link must be enabled to for proper downloading, so it will be it easily will get downloaded. There is no issue. And Rohit ji, without the data set, if you don't have the validation process cannot be over. If could I understood your question correctly then? Otherwise, you may ask for the clarification. Shushil ji is writing, can we take the data from image? No, we cannot take the data from image. Image type of data we can take. We can import the image. Whole data set we can import. In the CNN, tomorrow is going to whole lecture about the CNN. So here they will be demonstrated how to upload the image kind of data. Is it okay, Sushil ji? Tomorrow, wait for tomorrow. Tomorrow is a whole session for the CNN and convolutional neural network. You might have seen in the schedule. Okay, so they will, yeah, in the Amazon. The link is about the Amazon. You can upload it. No issue, no issue, and no issue. If the link is enabled to direct download, the data will be directly can be downloaded. Even from the server that required a username password, you can download it. You can feed the username password also over here. A lot of options like there. It's totally secure. Suppose your data set into the server, SQL server, and then the syntax you have to use where it talk about when you go for the database connectivity, you might have learned in the Java and the .NET. When the data need to access, the tables need to access from the data set, you need to provide the username, password, all those things. So that syntax is there, you can directly use it. So all the things are possible in the R also. Only matter of syntax. Agree? So about the sociology have asked about the image data. Wait for the one day. Tomorrow you will think you will see all how to upload it. Yes, yes, I will cover it. You might have seen in my schedule the day 4 and day 5th about the text classification. You please go to the schedule where I will demonstrate how to perform the classification in the text data. Abhishek ji, is it clear? Your question is over now. Yes, it is possible, and I will demonstrate programming point of view how to do it. And Rohit ji have asked a question. So when we train our model, There are validation accuracy and validation loss parameter, how they are different from testing in machine learning. Both talk about the different thing. Okay, they are vice versa, no doubt. The accuracy increase, validation loss also decrease. So any one parameter you can take it. Let me take question one by one. Rohit ji, these are the parameter to check the performance of your model. Either you can check the accuracy, always you want to increase the accuracy, or you can check the validation loss. Now loss means is error, you always want to decrease it. So both are the parameters, convey the same meaning, and you can take any of the one for demonstrating the performance of your model. It will cover, it will be covered if possible in the CNN or deep learning, because it is more talk about the deep learning oriented. Recording will be there, like in the I have shared a mail to all of you, and there were given link to all the lectures that have conducted in the part 1 FDP. All the 14 or 15 lectures are there. Similarly, all the lectures are being recorded over here. I will combine and will upload it into the YouTube, and a link will be given to you, or also that link I need to share with the AICTE. So all the lectures that are going to be conducted in the next 5 days will be available to you. So there is no 1% doubt over there about the recording of the lectures. It is clear?
Yes, sir.
Yes. Okay. So uh, like library files in the C++, we have seen the packages, or the name I might have, you have listened about the package. So like the R come with a lot of millions of packages over there. Packages means, suppose the simple version of the R you have installed, some of the algorithms, the functions of those algorithms are not available in the R. Suppose you want to work with the CNN. So you cannot write currently, if I going to call the CNN algorithm, any of the CNN algorithms, it will give the error because the functions of that algorithm is not over there. Suppose I'm going to use the random forest or decision tree or the SVM. I need to import and install the package that contain the solutions and the functions of those algorithms. So packages means any of the function or any of the operation you want to perform on your data set. If it is not with the R environment currently you have installed, you need to import, you need to install the packages. That package contain all those things. So package installation is very simple. Install dot packages is the code or is the syntax you have to write. Under the double quote, name of the package you have to write. Okay, so when you run that command, it will install for you. Install.packages is the command that will list you all the packages you have installed already. Remove package means the package working or function is over. You don't want to use that functions anymore. You can remove from your environment also. The next question is that you would use only RStudio for all demonstration or move to Python. Some expert will use the Python, I will use the R. So be with me. It is very much simple. Syntactical R and Python both are same. Some person will use also MATLAB, also possible. So throughout my lecture, I'm going to use the R. Some of the expert will use the Python also. Okay, Abhishek ji. Rohit ji are asking, I wanted to know how validation is done at the time of training only when we split the data explicitly. Yeah, it is called the cross validation. Yes, the validation possible during the training only in the form of cross validation. So if the time permit, 100% it will be there. Either Dr. Roja or will demonstrate about the cross validation. Please remind me if I miss it in coming classes. I will demonstrate the cross validation. So k-fold cross validation is a technique that is used to validate, calculate, or used to validation during the training also. Okay, so this is called training validation or k-fold cross validation. Okay, I will cover it. Or you note it down, k-fold cross validation. So please explore it. It will help you. Okay. Yeah. So there is a one command. df1 is a data set that variable name that contain all the data I know. I want to see the property of the data set I have just uploaded. So str is a command. You will see about, you see total number of 1338 observations means total number of rows is talking about. Total number of rows. Total number of rows. Okay. Total number of rows in the data set is what? 1338 and 7 variables. 7 variables means 7 features like 1, 2, 3, 4, 5, 6, 7. Okay. First variable is like a age. It is integer type of variable. A typical type of variable talking about. Gender is a character. BMI is a number. There is one difference between integer and number. Number means floating point numbers. So if you have a typical integer type variable, you are automatically recognize and label as an integer kind of variable. If there is a decimal numbers, they are designated as a number type of data type. And character. The most important thing I want to demonstrate, which is a categorical variable. How do you know it? Logically, you know gender is a categorical variable. Smoker is a categorical variable. Region is a categorical variable. But programmatically, how do I know which is the categorical variable or not? Because character is not a category. Here, it is not, female is not a category. Here, female means spelling only, combination of the ASCII value, FEMAL. So when I need to convert the particular variable as a categorical variable, what are the syntax? So here you see the character is a type of data type, but it is not a category. So because if there is a category, then the category may have a labels. Like a gender have a two labels, male and female. Let me check it. Label is a function already there. You can check any of the variable. If that is a categorical variable, it will talk about the sub labels. Let me run that command for you. Look, there is an error because the region df1. Let me write the correct name. Yeah, it is giving null. Means the reason I know it is a categorical variable having a 4 category, but since my R is not able to understand whether it is a character variable or whether it is a categorical variable. So explicitly, purposefully, we have to define, please consider it is as a categorical variable. So how to do all those things? There we have to use the converter that is called factor. Factor is a famous word in the data science, and factor is used for converting the character variable to the categorical variable. Okay, so I'm going to convert that variable as a categorical variable. So I need to change this because my data variable where the data set is stored is df1. Okay, so it is df, no error. Okay, now again let me run that command. You can see the comparison. str df1 vector df1. You see, earlier it was the character, gender. Now I have converted gender as a factor. Factor means as a categorical variable. You see, It changed. It is not, earlier it was showing as a character, now it is showing as a factor. Factor means technically is a categorical variable with two labels, female and male. Female was converted or represented as a 1 and male with a 2. You may represent as a 0, 1 also. You see the difference. You see the difference. Okay. In continuation, all the character variable in one go, I can convert it. So when, how do it? So when you are going to import your data in Sonnet or CSV, whatever the string variables are there, the string means character variables are there, convert as a factor, true. By default, it is false. You can make it true. And again, I'm going to upload the fresh data. You see, yeah. And the variable name where I'm going to store my data and giving the insurance name, enter it, str, run the same command, pass the insurance as a parameter. You will see factor, factor, factor with 4 labels. All things are there. So this is the way any type of, in R or Python, there is no typical type of data types that we don't focus on much about the data type. Okay, there is a category of the type of attributes like ordinal. The question is there, do we use any type of data types? So R and Python are languages that are not strictly work on the data type. The same variable can use the multiple type of data. Okay. Okay. So that is the things you might have seen about how to convert all those things. Okay. So that are the most important thing I have covered. Or you can use the table command to see number of observations in a particular categorical data, what kind of observations are distributed. Like here, you see table command you have to call, and you have to pass the variable that you want to analyze. Suppose region I have passed. So in the region, there is a 4 labels, north, east, like that. So there are 4 sub labels are there. These are the total number of observations in that labels. Somebody will ask how many genders or how many males are there. If somebody will ask, you need to pass only like that command. How many males, how many females are there? Here, you need to pass only this. You see, we have 676 males and 662 females are there. So the table command is used to show the distribution of the data label wise. Okay. Okay, summary is again the most important command that people use to see the first picture of the data. Like that summary command I have called, it talk about give you some statistical property of each and every features you have, like age. Whatever the age variable you have, the minimum value under that age is 18, medium is 39, first quartile is 27, mean is 39, third quartile is 51, maximum value is 64, like that. Fifth is an integer type variable. If it is a gender type or categorical variable, it talk about only the number of distributions to the label wise. BMI again is an integer type. You see the statistical property. The summary command sometimes will use to see the some basic and fundamental statistical property of your data set, so that you can understand how the data is distributed, how the data is related, how the particular features are biased or not, it is left skewed or right skewed or not. Based on the quartile, you can assume that. So that is the command the many people use is for this purpose. Okay. So okay, we have 5 to 10 minutes, so I'm going to demonstrate how to divide the data into the training and testing. So command is bit technical to understand, but I will try. The whole code I have written. Okay. So the simple first you have to find out the size of training data. Okay, suppose this is the insurance is the total data we have. What I'm going to do, let me first explain what I'm going to do. There are multiple ways to split the data into the training and testing. Whatever the data set is given to you, suppose in my case, insurance data is given to you. I'm going to divide my data into the training data and test data. How to split the data? So here 70% data I will split, and here 30% data I will split. So first I have to know how many observations are here. I think 1338 observations are there. I want to split 70% of that size of data as a training data, remaining 30% as a testing data. Okay, so what is the 70% of this number? That is going to be part of training data and remaining the testing data. Same things I'm going to work over here. You see, n row is a command that going to demonstrate total number of rows or total number of observations in the data. Okay, so like simple this command one by one I'm just writing. You see over here n number of rows. So we have total data size 1338. 70% of that data I want to take it out for the training purpose. Okay, that command is written 70%. I'm going to multiply, or 75%, you can whatever number you want, it doesn't vary. Suppose 75%, so you make it 70%, doesn't make any difference. So floor means, what is the meaning of floor? Floor or ceiling, the simple function I have applied. If number is a fraction number, suppose the 70% of 1338 is in decimal number, so I don't want to use the decimal number, integer value I want to use it. Okay, so some written correct. Floor means idea it going to convert one side down, one side up. It is, you may use the floor or ceiling, whatever you want. So we will talk about the sample size. This is the size of the training data set is going to be with me. So it is, I'm going to run that command and you will see the answer. You see, yeah, sample size. So what is the 70% of 1338? 936. 936 number of observations I'm going to take out from this data set and will make the training shape. You need to understand the training index then. What is meaning of training index? What is going to happen? It is a basic guideline in the machine learning. Suppose the data set is given to you. This data set is given to you, okay? This data set is given to you. So it is not desirable, or at all you should not do like that. First 70% record for the training and remaining 30% record for the testing. It is a disaster and you should not do at all. You have to randomly select the 70% data. Randomly. The random selection is important. The sequence selection is not desirable. Random selection means sampling you have to apply. Sampling you have to apply. Okay. So that's why which rows number I want to select first, third, 8, 5th, 8, 5, 8, like 9, 3, 9. These number of rows, this sequence ID you can say. The index means sequence ID or sequence number of the row randomly I am going to select. Okay. So that's why I'm going to create the index sequence number 1, 3, 4, 5, 8, 9, 20, whatever the randomly I'm going to select. That was sample function I have used, and out of which total number of sequence lane is what? 1338. Sequence lane is 1338, means the range will be from 0 to 1338. So it is talking about the range only. You will see that. This is the range 1 to 1338. Okay, remaining are 1338. So out of this range, randomly I am going to select the 70%. 70% is, or I think whatever sample size is there. So it is sample size. You see this sample size. Out of 1338, suppose 70% data I want to create. So 1003 number of uh, rows randomly I want to select. So those rows ID I am going to save over here. Okay, those ID I am going to save over here. You see. So what are the rows number of the training data? These are the rows number. You see, 626, 576, 1397. So these row numbers I'm going to take out for the training data. So these are the rows ID for the training data. It is not a training data. It is rows ID only. It is index only. It is not a data, because in the data there will be name or gender or smoker. Many kind of things will be there. So it is half work has been done. So these are the index. Now how to cut out the data? Okay. So we need to understand one command. Let me explain. How to use the indexing. So insurance is the data set. Okay, I want to access particular index start from 1 1. So suppose 1 comma 1. This is the first index I have accessed, 19. You see it is a 19. I want to print all first rows, first complete row I want to print. So this is talk about the row, I talk about the column. The first row I want to print, column, all the columns. When it make it blank means all. You see, all the columns. Similarly, first column, all the rows. Sorry, it never start from 1 and uh, uh, blank it like that. Yeah, 19, 18, 28, 33. 19, 18, 28, 33. First column I have printed. So here I've talked about first index, talk about the rows, second index talk about the column. So this syntax I'm going to use to create the final command. I'm going to find, yeah, train. Train is the variable that is going to contain the training data. So that command I'm going to use. You see, how many, which rows you want to consider? It is already there in the training index. It is already there in the training index. Which rows I want to consider? These rows. Randomly training index I have created, of the same size, like 1003, that is 70%. So training index 395, 1258, 668, these number of rows I'm going to use to uh, 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 consider for making the training data and all the columns. You see, now going to print it. Yes, you see, this is the training data. Now this data you can use for the training purpose, remaining for the testing purpose. How to use the remaining? Very simple command. How to create the test data? You see it. One line command, and very simple command it is. You see, I have used the minus sign only. So those number of index I have already selected, don't use it. Remaining index use for the testing purpose. It has created. You see the testing data. So any questions? Because the lecture what I thought about have completed, and if any couple of questions you have, please write on the chat box. I will try to solve it. Abhishek Tripathi ji, omitted data. Yeah, you can. Omitted data means the screen. In that screen, the whole data set is not possible to display. That's why omitted data. Omitted data means they are not able to display only. Data is there. There is another command. You can display the whole data, but you have to scroll down. Suppose there is a thousand of data is there. Lakhs of rows are there. How much time you have to scroll it down? So if data display within a screen, it can display, otherwise is omit. Omit means they are not going to display the data in the screen, but data is there. Abhishek Tripathi, it is clear? So do not confuse with omitted means it is there, data is there. Sandeep ji, I will take the attendance, don't worry about that, because at the beginning I have talked about randomly it will come. Attendance maybe in the next session and maybe in the third session, or maybe in the both the session. So it will come randomly. Attendance will be very important, strictly will be followed. Yes, can we use the online R2? It is there. It is there. It is there. I think online tool is there. Like a C, C++ programming you can do. So you can also do. No issue, Sandeep ji. The attendance is not over, so don't worry about that. So maybe to next or next to next lecture, I'm going to take the attendance. I will share the link here itself. So next lecture also be with me. I'm going to take the next session. So that will be talking about the fundamental, the neural network, uh, the deep learning layers, activation functions, backpropagations, and basic terminologies of the deep learning I'm going to cover in the next class or session, you can say. Because the tomorrow there is a two dedicated sessions are there about the convolutional neural network in the second session, and the last session will be on a recurrent neural network. So the faculty member experts will assume that you have a basic understanding about the neural networks. So purposefully, I have taken the fundamental about the neural network in the day one. So the next lecture also going to be taken by me will cover the fundamental about the neural network and deep learning. Thank you all the participants for your good comments. It's a reward for me if the time you have given to me and dedicatedly you are attending the lectures. So it should be fruitful only. So ultimate there should be a takeaway from the lectures. It not only be the only wastage of the time. It should not be only for the certificate. Certificate will be there. Okay, thank you. So thank you all for your good comments. So first lecture is over, and we will start the second lecture at the 11:30 with the time on time. Thank you. Thank you. Thank you. Thank you. So time will be followed strictly because the time is so important. And 11:30 we are going to start our session. Thank all the participants. Please, thank you a lot for giving this good feedback. Thank you. Sasi is asking comparison of R and Python. We will cover in last class sometime. We will discuss. We will have a small discussion about R and Python. There is a lecture. Aditi ji, there is a lecture. There is a two more lecture today. 11:30. The next lecture is I will take. Then third lecture will be on the yoga. It is a compulsory lecture suggested by the AICTE. So every day there will be three lectures. All the lecture will be followed as per the given schedule. So thank you. Take 20-30 minute break. We'll start. I think 11:30 is the timing. I a little 11:30 is the timing in the schedule. If you check it, it is 11:30 is the next lecture timing. I think so. Or it is 11 o'clock. Let me check it. Let me check the schedule. I'm going to share the attendance maybe in the next or next two lectures. Yeah, yeah. 11:30 to 1:30. 11:30 to 1:30, and then 3 to 5. Every day will follow the same schedule and timing. So we will meet again before 11:30. Please join it, and we will start on the time. So I'm not going to end the meeting. I will be here. So we'll join in after 30 minutes. Thank you.